Okay, hi everyone. Today is another episode of Archill podcast, and today I'm joined with amazing software engineers and tech enthusiasts, Dudu Povkadze and Sandro Dolidze. Hi guys, what's up?
Hey there.
Hello. Hi,
And
everyone.
I would love to ask you to introduce yourself. Shortly. Maybe let's start from Dudu.
Okay, no problem. So, my name is Dudu. I am a software engineer for like almost 5, 6 years now. I started working in Georgia at the beginning of my career. Then, after good community and help with my co-guest Sandro here, I started working remotely and have been working in the startups that got acquired right now ever since.
Perfect.
Okay, I guess it's my turn now. Hi, I'm Sandro. I'm a software engineer. So, currently, I'm working for a small Series A startup. I'm based in London, UK. Before that, I tried Google for a short period of time and I didn't quite like it. Before that, I've been freelancing for international clients for a few years. And yeah, basically, that sums up my career. I've been software engineer like professionally for about 7 years, but I've been coding for way more.
Amazing, guys. Thanks for introduction, and let me directly dive into our conversation. And the first goal and the first step I want to discuss with you is to figure out what browsers are internally, how they work, and what is this piece of software we are all using. So maybe the first question, just to kind of uh, be more precise. So we have some HTML file, right, on our computer, and usually like it's just a text file, and usually like every text file kind of by default opens in Notepad or some other text editor, but we have like this HTMLs opened in browsers, right? And usually like some this text document is translated to some visual stuff. However it does it, I don't know. Maybe like Dudu can tell us what's that process about, what are browsers, and things like that.
Yeah, so browsers has been around for a long time, and to go back in history, in the early stages, like browsers only supported the HTML. There were no place for JavaScript at the beginning. So to like go on the high level, whenever you open a browser and load some web page, there is some server somewhere around in the world, and it just sends an index.html page. It's basically a index.html is a collection of a markup language, markup code that represents how you want your website to be structured. Then browser internally parses this HTML. Then first it goes through all the scripts, style sheet links, title and stuff like that, and the parsing goes from top to down. And with that, browser knows how to like render each element, how to render each tag and stuff like that. And with parsing all that stuff, then there goes UI rendering stage, and you get yourself a website we use every day and every minute of our life.
Okay, amazing. Now let's kind of get one layer deeper. And what is this place where these things are rendered? I've heard that it's called DOM, maybe, or is it kind of part of the browser, or some more conceptual thing, or what is it?
DOM stands for Document Object Model, and at its core, DOM is a specification, like a structure of what the document is supposed to like. So at the first level, what you have is an HTML document which you have to parse. And once you're over with the parsing stage, then you somehow need a data structure that you save your data representation and also make those changes. DOM is basically the main data structure for the web and for all the UI. What happens is that DOM is usually implemented in very fast languages, usually C++, Rust, or similar, and usually DOM is stateful. And when I mean stateful, it means that like basically you can make some small changes. Let's say you have a button that is green. You can like say, okay, on click, turn this to a red, and basically you make a change. But the problem with this model that I have a one big data structure that is, by the way, hierarchical, which means that if I have a table and table has rows, basically rows have like their parent and the parent has the children. So it's like two-way two-way connection. So the problem is that for typical software engineer, if they're working with a complex application, that abstraction is not good enough because you're prone to write very brittle, very difficult to debug, and very difficult to understand code. And back in the beginning of 2000s, when people were using like libraries like jQuery and similar, they thought their lives would become easier, but they were able to solve bigger problems. But at the same time, the kind of state and the problems that they had to deal with became bigger and bigger. So very soon, the DOM and the DOM model to be interacted directly became very obsolete.
Yeah, and what about like this interaction with DOM? I mean, does it take like a lot of resources? Is it like when we kind of mutate the DOM? I mean, how about the performance issues there? Do we have some issues, some bottlenecks, or it's just pretty fast? Or
so one thing that I can say is that in almost every browser, and obviously it's slightly different browser to browser, the engine that does the DOM and the computations around the DOM is a completely separate system versus the engine that does other computations, usually via JavaScript or some other language. So basically you have two completely different systems. One usually JavaScript, the other one is some kind of DOM like engine. And for them to communicate like back and forth, because DOM is event-based, that means that DOM can invoke actions back to JavaScript and JavaScript can invoke actions back to DOM. That requires a serialized bridge. And if you're not careful, you may make so many changes within the DOM back and forth that basically it can become a performance bottleneck very quickly. So to answer your questions, if you're not careful, DOM will very quickly become your problem.
Okay,
Yeah,
amazing. Thank you.
I agree with that because before I was introduced to any JavaScript frameworks, I tried building apps with DOM, just directly with vanilla JavaScript, not using any frameworks, and it was like very first attempt to build a web page for me. And then I noticed when I went back to that code, I managed to slow down a single two-page application which had like almost zero content, that I think like giants now like Facebook and Instagram and stuff like that, very big JavaScript applications are much faster than my two single page application because I was using DOM wrong. I was doing too many changes with DOM and that was slowing down performance very much.
Also,
DOM
like
is
one
like,
thing sorry,
yeah,
like
go
I just
ahead.
want to like clear something out. Like whenever we say DOM being slow, so there's nothing fundamental that makes DOM slow. It's the way engineers interact with DOM usually. So like if any framework that we perceive as fast right now is in the end using DOM mutations, but the way they approach those DOM changes are very structured and very performance optimized. So like if somebody is like an excellent engineer and the only thing they care about is how to interact with DOM, they will write like code that will be optimal. But usually in real life, you have to deal with so many things and like DOM is so complex, you'd rather use some other tool that will solve that problem for you.
Yeah, and I want to add one thing. So we just jumped into how DOM works and how its performance and stuff like that. Stands for maybe junior engineers or people who are starting getting to know JavaScript world and website making right now. I want to clarify that DOM is the thing we use when all the JavaScript loads, all the HTML loads. There is a static web page without JavaScript. So when the page loads and we interact with the web page, we want to make some changes. But since the bundle and HTML is already loaded, we can of course load the new HTML, but that won't be like super performant and will not be user friendly. So we have a DOM for that, and with JavaScript we use this document model to update and change the UI inside the browser. So it does not load a new web page from, for example, when you click some button and it goes green. The new HTML is not coming from the server or something like that. It's just JavaScript doing its job with however engineers made it to do. And DOM is the way to execute those changes so user sees the after effect of your changes.
Okay, just to clarify what you just said. So is it like this, that we have this kind of a lot of components on the screen, UI, and whenever I update something, like basically I'm updating the very same HTML which we see, just some part of it, right? That's the idea.
Yeah. In the most cases, of course, there are other solutions, but mostly in the most common thing is that.
Okay, amazing, guys. Thank you for your insights about DOM. And now I just want to ask a bit different question. So whenever I go to search engine, let's say Google, right? And I have a website, let's say a personal website where I have some data of mine, some history, blah, 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 blah. And I search with some keywords which are contained on my website. And sometimes the search result might contain my website, let's say. How does that happen? I mean, how does Google or other search engines know what is the content of my site? Do we configure that, or it just happens by default by those search engines? Yeah.
Okay, in that case, I'll quickly go first. So like you've touched on a very hot topic, which is obviously search engine optimization. So first of all, disclaimer, like the way modern engines crawl things includes thousands, if not 10,000 or maybe more dimensions. So like knowing exactly what was the reason is difficult to tell, but we'll focus on the few key parts, obviously. So the first thing that happens is the process of crawling. So like Google, Bing, or any other search engine, what they do is they periodically search through the web and they try to basically see the web pages as a regular person would see. Sometimes they would try to simulate if it's a mobile device, it's a desktop, or something else. So they go to the web page, and when they go to the web page, what they usually see is some representation of DOM. So you have some kind of a structure, and that structure contains some data, some title, some header, some text. So the next part is that extracting those keywords and those data. And so basically where the data comes from has different scores. So if something is mentioned in the title, it probably has a higher score versus something that's mentioned in a text. But also we should be very conscious about the fact that like a factor of like you will never outrank New York Times, for example, just because the prestigeness and brand awareness of some brands and companies are very high. But like if you want to make your website presentable to search engines and make them more optimized, there's like hundreds of ways you can do, and there's a whole industry for that.
Okay, just one follow-up question there. You mentioned that the search engines kind of walk through these websites, but how do they know, like, maybe the addresses of those websites? Are they somewhere kept and they just take it out of them?
Oh, that's a good one. So we can basically look at like the internet as like a interconnected network. So like each page is linked by somebody else, and you're usually linking some other pages. So like we have this concept of like hyperlinks, and basically in any typical website, you're either referencing your own internal links, or in some cases, you're referencing some other links. So basically, if you start from a single page and you basically do some kind of a traversal, like, graph traversal, you will end up finding all the pages that they are in turn, as long as they're connected. And usually there's a high level of connectedness. So basically what crawlers do, the first thing they identify is that links to the internal links and external ones, and they usually follow the links until there are no more links to be followed.
Yeah, the first time I was introduced to that model, the first thought that came to my mind was like recursion, when you're trying to solve some kind of problem and split it in small chunks. Like you are going to facebook.com, you see Instagram, then you go crawl the Instagram, see all the links there, and gather that information.
So basically,
and also like one thing to small tangent would be. So sometimes it's difficult to discover some pages because like if a page is well connected, it's very easy to discover. But if a page is not that easy to discover, then it's a challenge. So there are a lot of tools for that. One good example would be a sitemap. Basically, a sitemap is a list of all the pages that your website has. So for example, when a Google or Bing or some other crawler comes to you, you can say, okay, by the way, if you're searching for my website, here are all 10,000 pages that I have, and you go have a look.
So you can kind of manually tell those search
Yes.
engines that you're out here. Hey, I exist. You can crawl me, something like that.
Yep.
Okay, amazing, guys. Thank you. And now, okay, one more question about browsers. I'm super curious. Like, we all have seen this Steve Jobs introducing iPhone, right? And he was flexing about this browser which was rendering HTML, blah blah blah, things like that. And is there any difference actually? I mean, for like, do like desktop browsers work the same way as mobile browsers do nowadays, or there are some differences?
I'll try to answer that question because I feel like I understand the question. So back in the day, it used to be that, like, I remember the initial iPhone, it was not able to render all the pages, and one big exception was Flash, because everything was Flash based back in the day, but like iPhone killed the Flash. Today, the difference is smaller and smaller. So the one obvious difference is the screen size and how you adapt to the smaller screen. So because you have a smaller screen, your constraints are very different. And also your product and UX is therefore very different. And also one thing to mind is also, I would say memory usage is, and like a memory and CPU are still interesting compared to desktop and CPU, like a desktop and mobile, because usually in mobile you have less resources, especially in memory. Like mobile devices have still much less memory than the desktop devices have. So if you're targeting something that's mobile first or mobile focused, you try to reduce your memory footprint. And the second thing would probably be CPU. So modern CPUs of like mobile devices are quite fast, especially if we say like iPhones or flagship Android devices. But more CPU you consume, more power you also consume. So if you want to be very mobile friendly, you should also be conscious about CPU usage, because more CPU you consume, more battery you consume.
Yeah, true. But when I started like working on the production level applications, the mobiles were so advanced that like most of the applications I built were designed mobile first. So the main goal was to uh, be the best version on mobile app, then go to the desktop and optimize it for the desktop version. So one more aspect about mobile development is optimizing bundle size, because of course good network and good Wi-Fi is not available everywhere. So whenever you want your application to be user friendly with good experience, it must download quickly on your user's mobile phone, because if we all have been there when some application or website takes forever to load, and that's really bad feeling, and most of the times you don't want to use that application anymore. So optimizing your bundle size, maybe especially for mobile, or doing some hugs. So for mobile you load some other paths and bundles that are specific for it, or some lightweight, because user don't does not need some part of your big JavaScript bundle at first or at the mobile phone, is a very good point to consider whenever building an application that will be used on a mobile device.
Okay, got it, guys. Thanks again. And now let me kind of leave this browser stuff behind and let's switch to JavaScript. And so the first question that comes to my mind is, why was JavaScript created? Like, the new language was created for browsers, and what exactly is a programming language? I mean, when we say JavaScript was created, was runtime of JavaScript created? Was some program which interprets JavaScript created? Was some set of syntax or rules created? Or, like, why did we even need to do that? And couldn't we just have used some other language and just put it in browser? And
Okay, so I will try to answer this question. I'm not sure if I'm 100% qualified to as a best history man for JavaScript, but I will try to answer it. So at first, when this web thing started and the people started using websites, it was just all HTML, plain text, and static websites. So there was no way to interact with any of the stuff on you see on your browser right now. So basically, like it's imagine a Wikipedia page just an information and some links, and whenever you click that link, it does not like show you loading screen or something like that. Just a new web page, new HTML loads, and you look at it. So this was a problem because internet was growing, people are starting using it, and of course, so there was a need for some interaction with the website, because as the complexity grew with websites, people started like creating accounts and stuff. If you want to create an account, of course, you have to have some kind of interaction with it. So they started thinking, so how to implement it. First thing I think, as I remember, was like putting some existing programming language in browser, but that was not like they tried it, as I remember, but with no success. They, as I remember, they had attempts to run Java in
Yeah.
browser, but as we see and as we are right now, in that did not work out. So they wanted a simple programming language that could be run in browser, that had a simple syntax and was easily interpreted. Was easily like easy to learn for every engineer to be able to create a new website with it. So they started working on JavaScript, and in time of 10 days, JavaScript was
Yeah.
born with its full complexity. And they wanted their syntax to look like Java, because Java was a hot topic in those times, and of course it would be like easier for other engineers to adapt. So they made it a little bit like Java. Also, JavaScript in name, Java is part of it, but as soon as they parted ways, and right now, as we know, they have no like same topics and stuff like that. But yeah, they wanted to. The main answer is for me that as the website grew, they needed some kind of way to interact with websites. That where JavaScript was introduced. And as JavaScript is just a programming language, and where it runs, it's called runtime. Browser has its own runtime, as Node.js, I think we will talk about this later, is a runtime environment of JavaScript that is usually used on servers and stuff like that. So JavaScript is a single uh, exception programming language that stands for its own, and the place it runs and place it is optimized for is other name called runtime. Sandro
I would
can give
just
more input about this. Yeah.
there's only one thing that I want to focus just because it's very important, and it's very ironic that the history is repeating itself. So like, for a language to be valuable, the primary thing that it needs to satisfy, it must have a clearly defined specification. So a specification is basically a list of rules of what the grammar of the language is, and what the standard library is, and what it's supposed to do. Like, every good language is supposed to have one. The problem with JavaScript for tens of years was that it never had a specification. So if you ask, what is JavaScript? People will say, go to Internet Explorer, go to Firefox, whatever you see and whatever you observe, that is the specification. So that's like de facto specification, which is very problematic, because one vendor would decide to implement things this way, the other one would do that way. And it took a lot of effort and many, many years to finally have a committee that would be responsible for the evolution of JavaScript as a whole, and also a list of things that JavaScript must satisfy to be considered as like JavaScript. The funny thing is that the same actually thing is happening with TypeScript. So TypeScript as a language is developed by Microsoft, and Microsoft didn't really care about specification of TypeScript, because like, it was their language, they could do whatever they want, like just like in Internet Explorer. So it's like the same thing. So now the compiler of TypeScript is itself written on TypeScript, so hence JavaScript, which is very, very slow. Like, JavaScript is not for CPU intensive applications. So whenever you have a big code base, you want to compile something very, very fast. JavaScript is a horrible language for that. Like Rust, C++, or maybe Go would be good choices. One of the reasons why there is not a good compiler for TypeScript written in Rust is because there is no specification. And every time somebody wants to implement something in Rust, they have to ask, oh, I wonder how the Microsoft compiler in JavaScript works, and if it works that way in the compiler, probably that's the specification.
Yeah, and speaking of TypeScript, like, can you also kind of explain like how we get JavaScript from TypeScript, and is it even kind of directly mapped between each other? Is it converted, or how does this process happen?
So TypeScript is what we call a superset of JavaScript, which is a fancy way to say that everything that works in JavaScript is supposed to work in TypeScript. But in real life, we rarely use it that way. We try to change JavaScript to more TypeScript ways. So I think in the history of languages, there has always been this big battle. So like, do we want more rules or more strictness, or do we want less rules and like more flexibility? And depending on the time and the project, some people preferred like strong languages that are typed, so like a number will never be a string. But there were times where people preferred dynamic things. And usually, like whenever you're talking about scripting languages, a language that is like a cherry on top instead of like a core thing, usually you don't think about types much. I think Python and JavaScript are two good examples of very popular languages that were intended to be cherry on the top, but as they progressed, they become core languages, and hence there was a need for like type safety. And so the type safety gives us a few things. First thing is that it's a very good thing for documentation. It's very readable, and you can understand what other engineer was thinking. Number two, it's very good for tooling. So if you're using any kind of IDE like VS Code, IntelliJ, or similar, like you have much better, like the IDE has better understanding of the language, hence it can help you very much. It reduces a lot of surface area for errors. So there's much less probability that certain kind of errors will happen. And I think there's probably some other good reasons for that, but probably those would be the big ones.
Yeah. So it's kind of funny of how I first got to TypeScript, because the programming language I was sufficient in university was Java. So when I started my first application in JavaScript, I felt like I was doing crime, because like just declare a function, name the parameters, and just use it. So no types and stuff like that. And I really felt like I was doing something wrong. And that's how I uh, discovered TypeScript. But I have some thoughts about that, because when I started using TypeScript, it was like very good, because you have a function, you define its parameters, like it's a string, one is number, and stuff like that, and that helps you. But as application grows, I have seen many open source projects and their type declarations that it's so hard to read their types that it's like separate science to understand. For example, if you are into libraries and how libraries are shipped and stuff like that, whenever you open a big, for example, React query is a library used for data fetching in React applications or any other framework. If you look into their types, it's like almost impossible to know what is going on. It's so complicated with all these nested types extending each other and stuff like that. So TypeScript for me is a simple typed language that helps us integrate our JavaScript with type safety. And whenever your type that you're defining is 100 lines long, I think you are doing something wrong. And it's like uh, for me as a developer, it's hurting my time, because whenever I, for example, I want to use a function that has already predefined parameters, and I have to spend hours reading it and how to structure my object to for this function to accept. I think it's a bad practice, because with TypeScript, I intend to make my application type safe and simpler. But with that kind of approach, it's like makes it much more complex. Of course, you have type safety with IntelliSense, but at the end of the day, it's how developer is accessing the code, how is reading the code, and if you make that experience worse, I think there should be a perfect golden ratio how much TypeScript is good.
Yeah. Thank you, Dudu. That was really insightful. And you like previously, before I jumped all of us into TypeScript, you were speaking of JavaScript engines, right? And let's kind of directly move onto that topic. So let's kind of discuss like what happens when simple JavaScript runs in browser. I mean, where does it go? Is there a program inside a browser which consumes it? What kind of? You also mentioned this kind of event loop mechanism, some concurrency stuff which is going on there. And can we talk a bit about that actually? How does browser actually execute JavaScript code?
I'll start and then you continue in that case. So let's follow the life cycle of JavaScript. So the first thing that happens is that when we go to any kind of website, we parse the HTML, and somewhere in some of the lines we'll realize this is a reference to a JavaScript file. So what browser will do, it's going to fetch the actual code for the JavaScript. So what happens after that, the first thing that we do for any language would be to parse the language. So we have to parse from something that is human readable to something that's machine readable. And the thing that we usually end up with, we call it AST, which stands for Abstract Syntax Tree. And basically what we have is like a data structure for code, what it's supposed to do. And there's a few things that we should be aware of. First question we should ask, what browser are we currently running? So for the sake of this example, let's say the browser we're using is Chrome. If we're using Chrome, the engine for JavaScript execution that Chrome uses is V8. So V8 is a very famous and very fast JavaScript engine, which is written in C++. And there's a dedicated team whose only responsibility is to evolve and make it faster. So what V8 does is that once it has this representation of the code, somehow it has to execute this code. But then here's a problem. So if you cannot directly execute JavaScript code because it's not a compiled language, it's an interpreted language. So you need some runtime. And the problem with runtimes is that if we don't have any kind of optimizations within the runtimes, they're very, very slow. So what usually happens is that there's two types of optimizations that are very common. One is ahead of time compilation. So what you can do is that you can look at the JavaScript code and directly convert this to like a machine executable code, like something similar to what C++ is outputting or another language. But that problem is it's very brittle and it's not very useful all the time. The second one, which is more commonly used, is just-in-time. It's called like just-in-time compilation. So what usually happens is that the V8 as an engine is basically doing some gambling. Looking at your code, it's going to predict what your code is going to do. If it sees that it's called like something that's like number, like 95% of the times, it's going to assume probably this is a number. If it's going to see a dictionary which is very small, like 10 entries or less, it's going to infer that it's always going to stay less. And it's going to make some speculative decisions of what this code is going to be, and it's going to run it. If it's going to be successful, it's going to be very fast. If it's going to be very slow, it's going to change it. And if it incorrectly makes something and makes it slow, it basically learns from it. So basically, the good thing with like modern runtimes and just-in-time is that it allows modern runtimes to execute very complex and very dynamic languages very fast. And another thing that we should be very conscious about is garbage collection. So JavaScript is a dynamic language, and because it's dynamic language, the resources are allocated from heap and also deallocate. Different engines have different ways they execute this. So most JavaScript engines are built for low memory footprints, usually 1 gigabyte or less, because one tab is expected to run in that kind of memory, unless we're in a server environment. And in that environment, usually the generational garbage collector is very useful. And what generational garbage collector does is that you have different buckets of these are the memory that was used last 5 times, 10 times, and so on and so forth. And every time you're promoted to newer tier, and all the old ones who are not used are basically getting deallocated. And basically that's how you easily and very efficiently manage memory in V8. I'm not going to get into very details because I know I've already talked too much.
Yeah. So that's really interesting. So Whenever I first was introduced to V8, it was like a black magic box for me. I had no idea what was going on. Just whenever you download your bundle.js on the browser, it executes somehow. So when I started looking into it, I found a very interesting blog post. It's on a Dino blog. Dino is JavaScript runtime, one of JavaScript runtimes. It was created by I think maintainer or creator of Node.js, if I remember correctly. I'm not
I think
sure.
Ryan Dahl.
Yeah. So the blog post is like it's a mini tutorial how to create your own JavaScript runtime, and basically Rust. Dino is written in Rust, and it gives you a power to use V8 inside your project. And whoever wants to get to know V8, how runtimes work, how JavaScript is executed, it's very good blog post. I suggest to read it and like make a tutorial or write your code in it. And the first thing I did was like you create a small project in Rust, read a file like index.js, give it to V8 V8 package of Rust that Dino provides, and you teach it how to interact with that code. For example, you pass to it if you somehow see console.log, call this function, and you define that function in your Rust project, like print out the hello world. If you see set timeout on the Rust side, there is a library called Tokyo with asynchronous stuff in Rust. Call that function and execute that function in the milliseconds provided. So basically, every runtime that JavaScript provides is doing that. It's mapping all the stuff that is inside the JavaScript specification. So if set timeout happens, like go to this library, set timeout, execute this stuff, and stuff like that. So if you want to know how exactly the engines work, it's very good exercise to read this blog, read, play around it. Is basically you have a V8 installed as a package, and you can make it parse and execute any JavaScript you want. So with that approach, you get to know the sense of how, for example, Node.js, of course, Node.js and SpiderMonkey and JavaScript core are very complex projects, but you grasp the main principles, so how it works, how exactly set timeout is executed, and stuff like that. So I suggest everyone
Amazing.
interested to look into that.
Yeah, I will definitely leave that blog in the description below. And so you just mentioned that like this is kind of mapping, right? Which this kind of engine does, like kind of takes JavaScript code and kind of executes it. But what about this asynchronous nature? I mean, let's say like we have this asynchronous processes or functions running, and is it kind of executed? Like I've heard that we have this single thread, which kind of loops around this process, and how does that happen in browser? And actually, like that's also a question. Like, what's the idea behind this concurrency model? Is it because of some browser limitations initially, or something else? What do you think, guys?
So first of all, no, like it was a very intentional decision. Like JavaScript could be like a multi-threaded language, and it is. We have now support for it, although it's usually not used. It was a very intentional decision, and one of the reasons why JavaScript is single-threaded is because it's very easy to reason about and very easy to write single-threaded code versus multi-threaded, and you have to like shared memory, synchronization, all the bad stuff. So you mentioned event loop, which is very useful. So I remember when I was writing one of my first websites, I was making like Ajax call. That's what it used to be called, and I wanted to get some data from the server. And when the server was giving me data, I was logging the output of it, and basically the output was always empty, and I just didn't know what was going on. At that time, I had no understanding of what asynchrony was. I did not know that there was a concept of like a callback. A callback is something when this will complete successfully or like fails, you just continue from that point on. like basically have to follow that and you have to thread through it. So basically, event loop is a very useful mechanism because, as we've said, like things that can change come from different ways. One thing is that DOM can change on its own, and DOM can say, okay, somebody hovered over me, so like do something about it. I made a network call, I have to react on when the response happens. Or there's like a timer, and like that timer is done, and basically I have to do something around it. So every of those things are put inside big queue, which is called event loop. And basically, one at a time, JavaScript is going to execute that, and it's not going to stop until there's at least one thing in the queue.
Yeah. So it took me a lot of time to grasp like how useful event loop is. It basically allows us to like the first when I started, as Sandro said, working with JavaScript. Whenever I like fetched something, I had no idea what was going on. If uh, some program was stopping and executing other stuff or something like that, it just worked by itself. So then I looked into event loop, and I can also provide very good blog posts about it, how it works internally, that it has different priority queues, one for example, set timeout, one for process dot next it. You can like schedule stuff for it. Also, there is like observer priorities and stuff like that. It's pretty complex but very interesting mechanism. So basically, whenever you click for a high level review, whenever you click something on web page and it starts loading, that's just a different code executing before the data you requested has been fetched. And the event loop allows us to not freeze the website while someone is waiting for data. And if you consider like a single threaded programming language without an event loop, if you start to fetch something, you can show loader because this thread is stopped until the data arrives, and then only you can continue. But with event loop, we can just tell the browser that's okay, I'm waiting for some data, but before the data arrives, just execute this function which shows the loader on the screen for user. And with that, event loop gives us opportunity to our website to be interactive and live, even when we have some asynchronous stuff going on under the hood. So yeah.
Thank you. And yeah, that internal working blog would also be great to share, I guess. And now, guys, let's kind of switch to the framework part and kind of some libraries which were built on top of this JavaScript, DOM, and traditional
Before
stuff. Yeah,
before we switch to that, I
uh,
just want to add one thing. We
sure,
talked
sure.
briefly about runtimes, and soon I think we will talk about React Native, and React Native's runtime and the engine is called Hermes, which is defaultly is shipped with. And right now, Hermes team is working on a very interesting project. It's called Static Hermes. It's basically is guessing, or if there is TypeScript or other types, what types you have in your JavaScript application. And for the first time, almost first time, it's considering the types with JIT. So it does not have to directly guess it. It just knows, it takes TypeScript code into consideration, and the machine code that it outputs is way more optimized and way faster. It's still in early stages, but the main guy of the Static Hermes project introduced it on one of the conferences. And if that thing works out with Bun.js and stuff like that, really good things are coming to JavaScript runtime, and fun period is ahead of time, yeah, ahead of us.
Yeah, pretty amazing sharing, I would say. And I guess this
Yeah.
kind of progress in React Native runtime might affect some other runtimes, right? Maybe web-based.
Yeah, of course. Like it's as think you know of Bun.js. It's new JavaScript runtime bundler package manager that was recently released and took whole JavaScript world with a shock. And it's already influencing other runtimes because like Node.js is making improvements and stuff like that.
Yeah.
So it's very fast developing Spectre right now because the other companies are working on it as well, and it's like a race who builds the best runtime for JavaScript for us.
Yeah,
Sandro,
let's.
have you looked into Pan.js?
I've only seen the logo. Looks nice.
Okay, yeah, let's see how far this competition goes between these runtimes and what we as users get. And now, speaking of these frameworks or libraries or kind of abstractions above this traditional UI stuff, and let's get into React, okay? And can you guys enlighten me? You already did, I guess, in the beginning of our talk, but can you tell me, I mean, what was the need to create such thing as React, and what problem does it solve, and why is it actually good internally, kind of to use React for?
I'll try to make it short in that case. The reasoning was typical. Writing more, getting more with writing less. So any kind of framework is promising you that. Uh, Making different teams and different code bases similar. If you're a company and you have 10,000 engineers like Facebook at that time, you really want all your code to be similar because you can move one engineer to a different team and they will understand immediately what they're doing about. Also, solve common pain points. And usually the pain points right before React released were just a few. So the one was how do you structure your UI that is conditional? So JSX really solved the problem because you can say I have an if, I have a for loop, you have the power of JavaScript, and you can render HTML. That was pretty novel at that time and really solved a very big problem. That was problem number one. Problem number one, two was how do you deal with state, and especially how do you deal with state change? Like every framework has their own way of changing things. React's way is basically virtual DOM and reconciliation. And basically what they did is that instead of making very small changes to DOM individually, you would batch them and like you would apply them as a batch, which would be more efficient. And basically it solved a very big performance bottleneck. So I think those were the big things from a high level. I'm sure Dudu has a lot more to say.
Yeah. So React, when I started working on React, like it was my first year after university, and I was at the point where I knew how to implement MapReduce in Go, how to reverse binary tree in C, but I had no idea how to write JavaScript. So I just went ahead and started writing some code in index.js, and soon I noticed that uh, whenever I want to make a change or whenever I want to reuse some component, I have to copy this HTML or keep my component as a template string. And whenever I have to interact with it, I have to get it from document by get element by ID or something like that. And that was the first time I came to React. And for me, as someone who was coming from object-oriented language, who was all about a composition and writing a clean code, React was the best thing that came to me because simple React is a perfect way for me to write a web application. But once Sandro told me that like it's very easy to be a to start learning React and making a simple applications with it, but it gets like super hard to write complex applications with React and manage it. So first thing that comes to my mind is it's all about like how you manage your state, and I think React has one of the best mechanisms for that. And the other part is how it's simpler to interact with updating your UI because React takes whole care of that. You don't have to care about any Tom stuff anymore. It takes care for it about it uh, from the beginning, and I think that's like the main points why React is very useful. And also, I think that React is very good framework for entry junior level engineers who are getting acquainted with how web works, how to write a web application because it has a very good learning curve and it's very easy to get started with.
Okay, cool. And now what I'm super curious about is all the rendering stuff with React. How did that model change in terms of rendering things on DOM, or is it actually the same DOM or not, which we knew before? And what is rendering? What is mounting of components? And can we speak a bit about this rendering stuff in React? How does that happen?
I will be as short as possible. So, main principle of how React renders is like first, as we mentioned about DOM, it parses all the HTML and generates a uh, structure that keeps all the state of the DOM inside it. And same model almost applies to React. React builds his React fiber tree. Basically, whenever you return some JSX from your component, then before React 18, Babel transforms it to React.create element, and with this function, React keeps in memory and creates a whole representation of your UI. And with help of DOM, in case of React DOM, it's basically a connector that connects your React Fiber to the DOM of your browser, and with all the React.create element function calls, it constructs a tree and renders all the elements of your application to the DOM. Yeah, basically that's the first stage of React rendering, creating a React fiber tree, keeping all the elements inside of it and their representations. How it changes after a set state or any change in the state, I think Sandro will give us more information about it.
I'll try not to go into too much detail and try to make it slightly more high level. So like I agree with everything that Dudu has said about the fiber trees and like the process of reconciliation in general. So like React has this fundamental assumptions that it's trying to verify always. So like the first assumption is that like if you make your changes in the DOM manually, in like tough times, it's going to be very difficult for you. So like there needs to be some step before that, and that was the step that Dudu was describing. And so basically, instead of us making a direct change to the DOM, what we do is we make that the very same changes to the memory, which also Dudu mentioned. And basically, there was an interesting observation from the React team that they did not know that because DOM lives outside the JavaScript, because it has to be serialized, it like the performance penalty increases. But JavaScript object creation and manipulation is very cheap, so you can create as many objects as you want and compare them to each other. So basically the step of reconciliation is, okay, here's what my previous UI state was like in JavaScript code, in JavaScript objects. Here's what it is right now. And could you please tell me what has changed? And if you tell me what has changed, we'll try to find the minimum number of changes necessary to update the DOM. So basically, if you want to boil down React into a few simple terms, it would be generally like you already have an old state which was already rendered. You have the current state that you want to render. You compare those two, you identify the changes between the two, and you only apply those changes to the DOM instead of the whole big thing. And that's the gist of React.
Yeah, it's React Fibers architecture is like really interesting how they are keeping all these your elements inside of the tree, and each element has access to it's like bidirectional graph. Like each element, for example, if you render a child component inside a parent component, the child has also has a connection to parent, and the parent has to all the childs, and even childs have connection to each other. So that makes it possible. So whenever you call set state, React finds the exact element where that state is located. It marks all the subtree as red, and then determines if what elements need to be re-rendered. Maybe if you have like wrapped it inside this memo or something like that, all that process is inside reconciliation, and only after the reconciliation the output is known, and that output is transformed then to React DOM, which takes care of how to express these changes in UI. React DOM is very interesting part of React that's often mislooked because it's basically, as we said about the runtimes, it's just mapping React's internal React core's functions to the DOM functions. For example, if it wants to update something, basically React DOM has a mapping to document get element by ID and then change the text node. React, like it's like a link between React core and output of React reconciliation to the browser page.
Yeah, got it, guys. Thanks for a brief description. And what about like some problems with React? I mean, uh, what is a kind of thing in React which can create some bottlenecks in performance, maybe, or maybe because of like we engineers do some things wrong? I mean, I have heard about this unintentional re-render stuff, and can that be the problem actually in small apps, in big apps, or I mean, what can actually be a problem with React when we're developing an application?
I'll just name a few and probably Dudu will add some more. So let's start with the usual suspects. So if your DOM is big, expect problems. Like not React, not anything else will help you. Like the bigger the DOM, the more problems it's going to have. Also, the structure of the DOM is very specific because if you have like big trees and higher hierarchies, DOM is usually built for that. But if you have like big many children, so let's say one node that has like 1,000 children or more, that's tough luck. DOM was not never designed for like very long, very many children, so that's going to be a problem. So those are the basic DOM problems. The next thing would be how frequent you update and you make those changes, because more frequently you make your changes, more likely you're going to run into the bottom like performance problems. We're getting to the React problems itself. So problem number one within React would be your virtual DOM can be big, and if your virtual DOM is big, you will run into problems as well. So even if even if your DOM is not that big, but your virtual DOM is big by using lots of fragments and like many hierarchies and like depth of the tree is long, that will be a problem. So you should be aware of that. Even if you do memorization, if you try to reduce the number of computations, then they themselves can become performance bottlenecks, because if your computations for what needs to be checked and what not is slow, that will also become a bottleneck. But in all fairness, in real life, I think the biggest problem that React currently has is probably hooks. Just because the mental mindset model of how hooks works is still unfamiliar to many engineers. It's very easy to miss very problematic points. So whenever I see something that is behaving weirdly, the first place that I look for, other than looking at DOM and virtual DOM, is it within the hooks and seeing are these hooks doing things they were supposed to, or did somebody accidentally miss something?
Yeah, true. I agree with every point Sandro talked about, and also I think one of the main problems with React is it's very easy to write a simple application in React, and like it will be super. In general, first of all, React internally does not have any problems with performance. It's how we write the code in React. And to write a simple application with maybe 5 use states and just keeping track of some once fetched data, it's very easy. But when the complexity grows and the application grows very much, it's very easy to miss very small minor details that finally affect your app's performance. For example, like when you write big React components, you should always think about how the data will move, where it moves from, where it goes. Like if you want to optimize the single component at the end of the sub tree, you maybe have to like rearrange all the page of the whole page it's being rendered on, because someone who wrote that page in the first place didn't think about how would data move in this flow, how you would pass it to other documents and stuff like that. So I think the main problem often for React comes from how we structure the pages, how we structure our components and stuff like that. Because when there is like super monster component with many children using like 10 plus hooks and stuff like that, it's very easy to miss a very minor detail. And after some time, when you are the one with the task to fix some performance issue or rendering issue or something like that, it gets very hard to find that minor bug someone missed. Maybe he's fetching some data not correctly, or some use effect is running when the person who implemented it thought that it wouldn't run or something like that. So I think React can be a very good and performant framework, and it's almost like very much depends on how you structure your application, what tools you use, and if you use and account everything React team is telling you to do. For example, the most bugs I see, not rare bugs like uh, not performant codes with big lists. React team like specifies that keys when you are rendering the list items is very important, and most of the developers like don't really look into that. They just give key parameter as maybe index of the array, and that like messes up whole inside optimization of the list components that React core taught a lot about how to implement. So yeah, I think the key to success with React is in minor details.
Yeah, so as I understood, it all boils down to kind of correctly using this framework, this library, and yeah, the most kind of issues
Yeah,
are caused by us ourselves, just like any other issues in software engineering
like
are
the
mostly,
most,
yeah,
most of.
done by us. Okay, guys, now let me ask a question, like not specifically about React, but in general, like UI project. So in backend, like we have some different kinds of complexity projects. Like maybe it can depend on user load, some scaling, etc. But what about like these front end projects? I mean, what do you call a complex front end project? Maybe a complex design, complex UI stuff. I don't know, some complex state management, or what makes UI projects complex, or front end projects in general complex?
I'm going to give you like my three reasons, but it's not the ones that you would expect. So, to me, a project is complex that is worked by multiple engineers concurrently. So, like more engineers, usually more complexity it's introduced. That's one. A second would be how frequently there needs to be a task that will take technical depth. Because usually in real life, what happens is that somebody creates a very nice UI, then the business comes and they come up with some solution. They really have to hack it because there's a deadline, and then you never come back to clean up, or when you come back to clean up, it's too late. Two and three, like tooling, like how much does the team worry about the tooling, about the project? Because chances are, if you don't worry about the tooling, you either you don't care or you don't need it. But if you worry about the tooling, you most likely really need it. So I think those would be my parameters for determining the complexity of the project.
Yeah, I also noticed that whenever a big team works on a front end project, it's for me it's more complex than when a big team works on a backend project. For example, like I had experiences whenever like a big team is working on some backend service. One team and one engineer has a different task here. It's a separate route for that implementation or something like that. But on front end, it basically at the end everything merges together, and that almost every time causes a big mess. And the complexity is like making changes with a big team, but not causing that mess and being like staying a bit simpler and not introducing a technical debt every pull request you merge in your project.
Yeah, got it. Amazing. And now let me kind of, it's been almost an hour we've been talking now, and let me slowly move to kind of end of our conversation, and let's touch React Native a bit, okay? And maybe like we can discuss like, is it exactly same as React, or there are some modifications? And like we know like React runs in browser, and what about mobile platforms, right? Where does it actually run? Is there a specific kind of browser-ish thing which runs on mobile, which on itself runs apps? And how does that work in terms of mobile? And what actually is this cross-platform stuff, the idea behind it?
Okay, I can start on
Yeah,
this one.
sure.
So, when I first started working on React Native, I only had a brief experience with native mobile development. It was like uh, well, I took one course about Android and one about iOS in the university, and that's all. Like I had no real world experience, and it's the React Native is just a part of React that allows you to develop a cross-platform applications, basically applications that can be run on web and on mobile devices, iOS and Android. And the development process is very well. It's um, enough. So if you are just a developer who has only been working on web platform, it's pretty easy to get started on. Of course, when the complexity grows and you have to add like some specific stuff, you want a native libraries and stuff like that, you need to have some kind of knowledge about native platform. But other than that, React Native is basically you write a React code that can be installed as an application and used and downloaded from iOS Store and Google Store and stuff like that. Internally, the main difference between React and React for Web and React Native is uh, the React DOM we mentioned. For example, if with the React for Web application, the React DOM is responsible for translating the changes from reconciler to the DOM. And for React Native, for mobile browsers, mobile phones, and iOS and Android, we have a React Native for that. It basically from your whenever you set state or update state in React Native, uh, a reconciliation algorithm take care of it, determines what changes need to be made. But in case of iOS and Android, it hands off these results to React Native, and then it has a React Native has a link to the native platform, which is responsible for updating UI or making any changes on the mobile device. Basically, the main difference is implementation of what happens to reconcile the output of the React code.
So as I understand this, React Native kind of talks to the native machine, right?
Yeah.
And does it kind of tell it to kind of, hey, Android, just show this on UI, or it kind of translates some code and then that code works on a native machine, or how does that happen? Uh, is it only about communication, or there are some other things happening as well?
Hmm. As far as I know, I may be misleading about it, but there is a bridge between React Native and the native platform, which translates, for example, you have a view, which view is a component in React Native, which if you run this code on web browser, it will be translated to div. And if React Native
Yeah.
is run on mobile device, for example, Android, it translates it to Android.view element, which is on the native side, and React Native takes care of translating your code to the appropriate destination and
Yeah.
appropriate link, providing a appropriate component for the platform you are running it on.
Yeah, and previously you mentioned this Hermes, right? And this Hermes,
Yeah.
does it leave? Does it ship with an app when we
Yeah,
download it? Yeah.
it's shipped with your application whenever you, well, you can change it, but as the default React Native application ship with Hermes. Then whenever you bundle your application, it goes with it, and whenever you someone downloads it from Apple Store, Play Store, it's already in it, and it takes care of the JavaScript side of things. Of course, you can configure it, for example, on iOS to solely run on JavaScript core, which is an engine running inside the iOS OS. But yeah, Hermes is shipped to your
Yeah.
application if you want to.
Okay, guys. First of all, I think that's gonna be all for today. Thank you very much. It was super exciting and super thing to talk to you about these interesting topics. And maybe like for the final thing, like I know like you both are super excited about JavaScript, React, etc. But can you just tell me like one technology passion maybe, or one side hustle which you do like besides JavaScript, maybe some training technology or just whatever it is, just out of curiosity.
Okay, I can name one thing that I have been really passionate about lately. So recently, I was really into interpreters and compilers and making some programming languages that can be that you write your own interpreter compiler and like see how it works and play with it. How far can you go? But right now, as a side project, I have been looking into a torrent specification. Like if someone is interested in um, how the BitTorrent, uTorrent, and stuff like that work. It's a really interesting technology. How you share your files and how you download files from others' computers. And the most interesting thing about is that all the engineers who are starting recently or like working on ordinary jobs as me are accustomed to like you send HTTP request with the JSON body and you return the you get back a JSON result that you parse. But with BitTorrent protocols, you are gonna use UDP for file downloading, and you just build request bodies from buffers, just on the bit levels, and it's really interesting, and it's like good to jump from just some CRUD operations and JSON outputs to that kind of world. And yeah, I suggest if everyone is interested, try to implement your torrent client and see how it goes.
Amazing. Thanks, Dudu.
Cool. So for me, the company that I work for uses this tool. It's called Retool. So basically, it's a low-code, no-code platform to build backend dashboards and like back office applications. So a typical use case is that if you have something that like you need like a table, a list, or like buttons or something like administrative stuff, you don't want to build yourself from scratch in React. You don't want to spend the time. You can really easily build with them. There's a lot of platforms that do that, like Retool specializes in back office things. Like one thing that I was completely blown away is that to me it's like a next level thing because it used to be like vanilla JavaScript, vanilla HTML, JavaScript, then we had frameworks, and now we have like fully fledged studios that do a lot of things. Like you can sprinkle JavaScript, you can write conditional logic, you can make API calls, you can use third-party libraries, and I'm just amazed by how many things you can do with their own built-in libraries and things. Like basically, if somebody were to tell me, "Hey, I have like a database or like API, how long can you build me like very simple front end that I can use?" Like it's a matter of like minutes and hours, not like days and weeks, which is mind blowing. Obviously, there's a trade-off. You cannot build like very rich UIs. It's usually not good for like user-facing high UX, high fidelity environments. But if you're doing something for back office and you just want to make it work, boy, it's amazing. Like I'm just blown away how good this abstraction layer is. And I feel like a lot of engineers today who use custom components in React will soon like go one step up and use this kind of studios to develop most backend applications.
Yep.
Interesting.
Super interesting and super insightful, guys. Thank you once again. I had really...
Thanks for inviting.
Yeah, that was amazing, and
Yeah.
hope to see you again.
Have a good one. Thank you.
Yeah. Thank you for inviting.